Hi and welcome to this new video in which I'm going to show you a practical use of what we have saw in the previous example. In this example, I'm going to show you how I'm using semantic kernel in conjunction with kernel memory, or you can use with every RAG pipeline you have to do query rewrite. The idea is this: when you have a RAG, retrieval augmented generation conversation from user with your data, you usually start with a question and the server answer with some answer. Then you can post a follow-up. So you create a new question. And the problem is when you use that question to search inside your database, both with keyword search or with vector search, the problem is the query should be rewritten to be put in context of the conversation. And let's see an example on how you can do this operation with very few lines of code thanks to semantic kernel. So this is done very simply with handlebar. So as you can see from previous example, we know that we can call the create function from prompt method from the kernel object, and you create your prompt. In this situation, I give a name to the prompt. It's called test rewrite. I have a description, and I have a template that is using the handlebar syntax. So the idea is I have given the following conversation history and the user next question, rephrase the question as standalone question. This is a pretty common prompt that allows you to say to the large language model, hey, I have this conversation and I have this question. Can you rephrase that question in the context of the chat so it is a standalone question? And then you need to put in this prompt all the previous chat and the new question. And thanks to the handlebar template, as you can see, you have each history. Okay, so you have a pseudo language where you can have a for each like cycle in which you say for each history object, you say question and answer and you finish the each. So this is like a for each in the parameter you are specifying to this prompt. And then you have follow-up input, and this is the chat input. And then you finish the prompt with the standalone question. So you are eliciting the large language model to continue. And as you can see, you need to specify that the template format is handlebars because it's using that for each syntax you saw before. And then you have the input variable. So you are describing that this function you have two input variables. The first one is the chat input, and it's the new question of the user. And then you have the history, and this is all the history of the RAG check. And you can have is required, you can have default. As you can see, you have a very powerful way to specify your prompt. And clearly, you have the execution settings, so you can specify the number of token. And as you see in a previous video, in the fourth video, you can specify with model ID the model you want to use for this task. So you can use GPT-3.5 or you can use GPT-4, but you can specify everything. And as a final touch, you absolutely need to specify the prompt template factory. And you need to have a handlebar prompt template factory. And this is because the template format is handlebar. And as you can see, this is a very powerful way to specify a prompt with some kind of meta language that allows you to compose a string. As usual, this template is hard-coded in the source code. In production code, I strongly suggest you to put this into a configuration file, a database, so you can tweak as needed. And it is especially needed if you start using a new version of the language model and maybe you need to tweak the prompt. Really simple, few lines of code, you have a powerful template that you can use to rewrite your question. And here is how you can use this. You have a chat input, it's the new question of the user, and do you know a similar technique? So you understand that this question makes no sense if you don't have an history of the conversation, so you cannot use this question for a keyword search or for a vector search. So you need to have the context of the conversation, that is the history. As you can see, this was taken from an example where the user previously asked, can you please explain complete mediation? And then the RAG system specified that blah, 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 yes, I can explain you complete mediation. And now you say the next question is, do you know a similar technique? So very few lines of code, and you can say result is kernel invoke async, and in this situation, I pass the chat object I get before. Okay, so the chat object is the definition of all the prompt, all the rules. And the kernel arguments contains all the settings you want to override if you want this, and all the parameter. And as previous example, the result is a complex object, but in this situation, I'm not interested in all the complexity of the object. I could examine getting the number of token used and blah, blah, blah. But the only thing I'm interested in is the string response of the large language model, so I can simply use the toString to dump the answer. Let's see what's the output. Now I'm running all the notebook, and the result is result. Do you know a technique similar to complaint mediation? So now this is a standalone question that you can pass through your RAG system, use it in keyword search or vector search. And this is important because it shows you that Semantic Kernel is, yes, a powerful library that can be used to write plugin, and we will see a lot of amazing things. But even if you start learning this very basic interaction, so the ability to create a prompt, create a complex prompt with handlebar, managing settings, being able to choose the language you call, it allows you to use in a completely different environment. So when I'm working with kernel memory, or when I'm working with my personal RAG function, and I need to make, as an example, a query write, it is very simple using Semantic Kernel to define a prompt, being able to use handlebar syntax, complex syntax to create a prompt, and in a few lines, invoke the prompts and obtain a result. This is very powerful, and this is one of the things I like the most about Semantic Kernel. It's a library that it can be used to do amazing and complex things, but allows you to make this kind of interaction with a large language model in a very simple way. So it makes simple to interact with a large language model in a very interesting and powerful way. So in the end, Semantic Kernel has a very basic interaction with the large language model capabilities, but yet these are very powerful because it allows you to make simple call to large language model. You can use powerful syntax. You can register multiple large language model and choose which you use for each call, and make simple invoking a large language model, having a simple result with two strings. So you can invoke and having a string, but yet if you need to understand the real answer of the large language model, you can use and you could access the real deserialized object that came from the API. So you can use Semantic Kernel in your software because, and you should use Semantic Kernel if you do not want to directly interact with the API. And as a bonus, if you are interacting with the large language model with an API, if that API changes, you need to change your code. And if you are having a very basic interaction, Semantic Kernel abstract this for you. The large language model updates, Semantic Kernel will have an updated version of the library that knows how to code the new version in the library, and it does everything for you. And this is especially true for the function call you see in the fifth video of the series, because you can define function in an abstracted way, and it's Semantic Kernel that takes the responsibility to perform the right call to the large language model. And also, you can use Semantic Kernel, and this is the best basic functionality that it is offering, and the one I use the most is the ability to use a powerful template prompt syntax using handlebar, for example. So you can have a series of prompt that contains a pseudocode that allows you to build a complex prompt, and you can store everything in a database, in a file, and Semantic Kernel allows you to grab the string, configure everything, so you can configure the large language model to use, temperature, everything, and create a unit of function code that you can use with one line of code, passing only the parameter that will be used with the prompt. So even if this is a very basic interaction, I strongly suggest that if you need to start using Semantic Kernel, you understand that it has not only powerful plugin capability that we will see in future video, but it has strong basic capability that will make your work of interacting with a large language model much easier. Bye bye. And as usual, if you like this video, please subscribe to this channel.